Hello everyone and welcome back to my channel. Today we are going to be understanding the basics of networking, that is how two devices in a network communicate with each other. And for this we are going to be using a tool called Wireshark, which is an awesome tool with which we can capture all the traffic in a network. We can see all web requests made, even capture FTP and Telnet passwords that I'm going to show you today. So I have my Kali Linux machine running over here, and I have Metasploitable running in the background, and both of these are connected to the same NAT network, attached to a NAT network. Both of these are connected to the same machine, and my Metasploitable machine has an IP address of 10.0.2.6, uh, and my Kali Linux machine has an IP address of 10.0.2.5. So let's open up a new terminal, and I'm going to increase the font size. Now, not every user can capture data using the tool Wireshark. To capture data on Linux with the Wireshark tool, we either need to be in a group called Wireshark, which does not exist on Kali Linux, or we can either run Wireshark as the super user, that is, run it as root. So I'm going to do sudo Wireshark and enter in my password. So this will launch the tool Wireshark. Now Wireshark has detected all these interfaces on our network. So this is the virtual network ETH0 on which it is capturing some data. I don't know how it is capturing it, but anyways. And then we have the loopback address, which is a loopback interface, which is a special interface on every device. So the IP address for it is 127.0.0.1 or ::1 in IPv6, which can be seen when I hover over it. This is a special interface or an IP address which points back to the device which uses it. For example, if I can use netcat to connect back to my own device. Instead of specifying the IP address 10.0.2.5, I can say netcat 127.0.0.1. So it will connect back to the same device, and it is device independent. So this exists on most of the machines. But enough blabbering, let's start capturing data. So I'm going to double click on the ETH0 interface, and it's going to start capturing all the data. Now this is completely blank since there is no traffic in our network right now. There are only two machines. One is half asleep, that is the Metasploitable, and the other Kali Linux machine, which is not communicating on the network right now. So before that, what I'm going to do is go to edit preferences, and I have already increased the font size so that we can see better. Just if you want, you can also increase the size from here. It took me quite a while to find it. And so this is capturing all the data on the network. So let's open a browser to generate some traffic on the network. And as soon as I open a browser, notice all the traffic that's being sent. Now the let's just make this a bit smaller like this, and bring this also a bit down. So as you can see that Wireshark is really flexible, and we can see a lot of protocols being used in the background. So our source IP address to the destination IP address, this 192.168.1.1 is most probably our router, and this is using the ARP protocol. We can hijack this also. Then we have DNS, which is something else in itself. We will talk about many of these protocols in our coming videos. Then what is happening is Mozilla in the Firefox in the background is accessing cdn.mozilla.net and some other websites just to make sure that it is online, and if there is any update, security patch or something, sometimes you might see that it prompts you for updates. So all that data is being captured. We can see that it is TCP, and we see that a three-way handshake is taking place. The ones highlighted in gray, these represent a TCP handshake taking place, three-way handshake. So first we sent a SYN packet to port 443. Now 443 is the default port for HTTPS websites, the secure ones. So we see a SYN, then we see a SYNAC. Let's try to follow this. So we see another SYN, another SYNAC. So we send a SYN packet from 10. That is a source, our IP address to this destination, a SYN packet, and that IP address responds with a SYNAC packet. So Wireshark is full of tools, and we can see that it's captured quite a lot of packets and more are coming in the background. But this is all based toward DNS, ARP, TCP. But let's try to do something else. Let's visit the IP address of the Metasploitable machine 10.0.2.6, since we already know that on port 80 it is listening and has hosted a web server. So let's visit that website, and this is the Metasploitable 2 web page, which we are going to be exploiting in the next coming videos. And we can already see that it generated a lot of traffic. I have to scroll down a lot, and we see HTTP protocol in use. Now HTTP is the protocol of the internet. All communication on the internet of websites mostly takes place through HTTP, the hypertext transfer protocol, which we are going to discuss in our next video. But for now we can click on this red button to just stop the capture, because this has already grown immensely. And we can take a look at this first HTTP request. So HTTP requests are GET or POST requests. So we can see that it is telling us a lot of information about this request, but it might not make a bit sense. We will discuss all of this in just a few moments. So we can see that it has got a lot of data saying that it is this much bits, what protocol was used. We can see that it is TCP, source port, destination port, and we can see that it states it's hypertext transfer protocol, and we have the raw request which the browser sent to that server. So where did that request go? So I'm on this request, and we can see that it sent a 200 OK. A 200 OK means that I found whatever you requested, and here you go. Here I am sending you an HTML web page or a video or something which you wanted. So if you just click on this line-based text data right over here, and we see the exact page which is visible in our browser. Now this is written in something called HTML. You can search Wikipedia for it, which is the language of the web. On our browser we can press Ctrl U or just right click and view page source, and this will show us the raw HTML code, and this is exactly the same as of the Wireshark, which Wireshark is showing us. What we can also do is, if this was a very busy network, then we might not be able to make sense that okay, this HTTP 200 OK belongs to this request, or it was in response for this one. So what we can do is use one of Wireshark's many features, is apply a filter. So what are filters? Filters allow us to sort all this huge amount of data based on our requirements. So right now we can apply some filters like IP.src. IP.src, which stands for source. So if the source of IP is equal to, so for equal to we use double equal to signs 10.0.2.5 and press enter. So this will show us all the traffic in which our device is the source. So our device is responsible for all that traffic. Okay, we can also, instead of doing IP.source, we can do IP.dst, which stands for destination. So if the destination IP address is equal to 10.0.2.6, so this will show us all the traffic which is being sent by any IP address to the 10.0.2.6 IP address. And we can even combine two filters together. Okay, so let's say that IP.destination is 10.0.2.5 and ip.source is equal to 10.0.2.6. So notice that we have combined two filters together to show us only that amount of data which is being sent from the Metasploitable machine 10.0.2.6 to our Kali Linux machine 10.0.2.5. So this is really helpful. Instead of and, we can type in two ampersands which do the same job, and instead of using and, we can also use or. So if the destination is our IP address, or if the source is the Metasploitable machine, then show us that traffic. Now this is not a very useful filter, but enough to display the or. So instead of typing or, we can also use these two pipes which do the same thing. It is located above the enter key, and we can also filter for specific protocols, like if you want TCP, now this will show us only TCP traffic. If we want, we can filter for UDP. So DNS is based off UDP, that's why we can filter for HTTP, and this is showing us all the HTTP traffic. Now let's combine some of our filters together. So HTTP and IP.source equal to 10.0.2.5 or IP.source equal to 10.0.2.6. Now this is for checking equality. If we want to check that if it's not equal to, we can use exclamation mark equal to, which in many programming languages also stands for not equal to. Press enter and we have all the communication in which these are the culprits. So let's just try to enclose this in parentheses. Okay, so I don't know why it's not working. Anyways, so we see that we have found out the GET request and its corresponding response, but let's do something. Let's use a feature of Wireshark. We see the first GET request, just right click on follow HTTP stream. So what happened? We got all the data, it filtered out for us. So Wireshark is really smart. It filtered out what we sent. So what we sent is being displayed in red, what the server responded with is being displayed in this blue purple color. So we send this GET request to the server which Wireshark has identified, then it identified the corresponding response which we received, and then the connection did not terminate over there. It requested a favicon.io something .ico, and the server responded with a 404 not found, saying that favicon.io ICO was not found on this server, and it says that it's an Apache server and something. But this is really cool, so we can follow everything that was sent between the server and the client. Now in this case, the client was my own PC, but in some cases you can even capture data of other people also, which you should not do since we are good guys. Now this was a lot of data, so what I'm going to do is start the capture again, and this time we are going to capture FTP and Telnet passwords. So I just find, instead of clicking on that button for Wireshark, I just find it easier to quickly reload this because it sometimes gives me a problem. Otherwise you could just click on stop and click on this button to start capturing packets again, but I don't know, Wireshark gives me some problems with that. Okay, now let me just close the browser so there is no traffic in the background which has already been captured. And now we know that there is an FTP server running on the machine, that is Metasploitable machine. So let's connect via FTP, username anonymous, password anonymous, and we can see login successful and a lot of traffic on that network. Now let's just filter for FTP, and this is a lot of information. So we see that as soon as we connect over TCP, the server responds with this banner. Then we send a user anonymous. Then it sends us a please specify the password. We specified the password anonymous. And what the syntax that we see is how the FTP protocol works in the background. So we can right click, follow TCP stream, and this is all the data that we captured. So the server sends us this banner. Now to verify this, we can just open another window on our terminal, use netcat 10.0.2.6 port 21, which is for FTP. As soon as we connect, we receive this banner, as we can see over in the Wireshark, and then we can specify user anonymous. It says please specify the password. We say pass anonymous, login successful. So this is how the FTP protocol works under the hood, and we have successfully captured the username as well as the password. Okay, so that is why the protocols which communicate in plain text are really dangerous. Next, we can use the Telnet command, which is just like SSH, and both of these allow remotely logging in into that machine, but SSH is encrypted and is really secure. Telnet transfers data in plain text just like FTP and HTTP. So let's do telnet not found. Why telnet is not found? Sudo telnet. Do I have telnet? Sudo apt install telnet, please. Okay, it is installing this. Might take a minute. Finally, so telnet 10.0.2.6 and connected, and we see the same prompt. For now, let's just assume we know the password, msf admin. We are logged in. We can do ls vulnerable, that is the directory. Now instead of let's just remove this filter and let's search for telnet, and we can see the telnet traffic. Right click, follow TCP stream. It's become a habit, and we can see this prompt, which was the prompt we received as soon as we connected to it, and the banner never exposed this VM, and then a login. Now you can see that every character is being displayed twice in our login. As soon as I hit M, the red color is means that the M is sent to the server, then the blue is that the server echoes it back. That's why sometimes when we are logged in via SSH or Telnet, it takes time because our keystrokes reach the server and then are echoed back to us. So we can see that the username or the login is msf admin, password is also msf admin, and same with the commands. Each character is repeated twice because once it is sent to the server and then received back. So we have successfully also captured the telnet credentials. Okay, so now I'm going to just exit out of this, and now I'm going to filter for FTP traffic again. Let's go to the first banner, and now with the help of this packet, this data that Wireshark has captured, let us try to understand how these devices were able to communicate. And just before I do that, let me just stop the capture because it's becoming really long. And now let us try to understand this with the help of the OSI model. So let us understand how two devices on a network communicate with the OSI model. So the OSI model, or the Open Systems Interconnection Model, is a model that standardizes the communication between two systems in a network without paying attention to the technology inside of it. So this was developed at a time when the computers of one manufacturer were only able to communicate with the computers of its own developer. So for example, if I have a Lenovo laptop and a Dell laptop, they were not able to communicate at that time. So this was developed as a standard so that the computers of different developers could communicate with each other. The OSI model is divided into 7 layers. From top to bottom, these are the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Let us look at each of these layers briefly. So the first layer is the physical layer. The physical layer is responsible for the transmission and reception, that is receiving the data between a device and a physical transmission medium, which can be Ethernet or Wi-Fi or any other medium. It converts the digital bits or the data into electrical, radio or optical signals. Let's observe the physical layer in our FTP data packet. So the first section in our Wireshark capture of this packet is displays data of the physical layer. So it says frame number 13. So this is the frame number 13. 86 bytes on the wire, which means 688 bits, and it has captured all 86 of those on interface ETH0. Okay, so Wireshark thinks that it is connected to a network through an Ethernet cable, which you might have seen which is plugged into the computer or a router or something, and it says that it captured 86 bytes of it, or 688 bits, and it has encapsulation type and a lot of data, frame number which is 13, the frame length, captured length, and many other things which we do not require if you are like me and do not know anything about these things. Unless you plan on becoming a network engineer, you might not come across these things, but they are still important to know. So what is encapsulation? We are going to discuss it a bit later after we discuss all the layers. So this is frame number 13, the 13th frame which has been captured, length 86 bytes, time from previous captured frame. So this was captured 0.002 something seconds later, time from epoch, which is the way time is measured in Unix systems, which is a time from 1900 something. The time lapsed till then, I do not remember the exact date or year. So the number of seconds elapsed from that time. We have the arrival time, encapsulation type, which I told you we will be discussing a bit later. Then coloring rule name, TCP, how it has been colored, is the frame ignored or marked, which is false, and the protocols inside the frame. Now this is important. So we have ETH, ether type, IP, TCP, and FTP. Now these belong, or these tell us the protocols used in the above layers. So this FTP is used in the application layer, TCP is used in the transport layer, and IP is used in a network layer, and so on. So this is telling us information about the above layers. So this was the physical layer in action in our Wireshark capture. Next up, we have the second layer of the Osi model, the data link layer. The data link layer provides node-to-node data transfer, a link between two directly connected nodes. So what is a node? A node is any device, a computer, laptop, mobile phone, anything connected on a network. So its main function is to make sure that the data that has arrived is error-free. The data link layer is also responsible for making sure that the data is transferred properly using the MAC addresses of devices. This a MAC address is basically an address which is present in all the network interface cards, or the NICs. It is basically burnt into that card and it cannot be changed, although it can be spoofed. Next, let us observe the data link layer in action in our FTP packet. So the second section represents the data link layer. So it is the Ethernet 2 protocol. Source is this MAC address and the destination is this MAC address. So source IP address, destination IP address. Source I think is our IP address. Let's just do ifconfig. So 10.0.2.5. So let's take a look at our IP address. If you just do ifconfig and this is the IP address of my device. So 275C. So the destination MAC address is my MAC address and the source MAC address will be the MAC address for Metasploitable machine. So we can just do over here also. Let me just minimize this thing. If I just do ifconfig, you can see the MAC address. It should be somewhere over here. Where did it disappear? Okay, so HWADDER, and I cannot hover over it with my mouse, so I'll just highlight it. So you can see that it is 0800274007C5. Let's just go to Kali Linux and we can make sure that 0800274007C5. So this is the source MAC address that is of the Metasploitable machine. Now we have some more data over here, which I will be frank that I do not know about this, but this has something to do with the MAC addresses, I believe, and it says that the type is IPv4. So this is telling us that for the next layer that it's telling the next layer that it will be Internet Protocol version 4. That's why we have on our next layer the Internet Protocol version 4, 10 and the IP address in IPv4 format. So this is what this thing is telling us. So I really do not know what this is. Next we have the layer 3, the network layer, which provides functional and procedural means of transferring data or packets from one node to another which are connected in different networks. So it is responsible for locating the destination of our request and determining the best route to take. And it uses these logical addresses, which are IP addresses. So we have two types of IP addresses, the IP version 4 format and IP version 6 format. Now the IPv4 is the most commonly used one. So now let us see the layer 3 or the network layer in our Wireshark capture. So this is the same FTP packet. We can see it is using the Internet Protocol version 4, and that's why the IP addresses are in the IPv4 format. So source IP address, destination IP address, version, we have the header length, and then we have the length 72. Now you might notice that from the physical medium we captured 86 bytes, but as we progress up, as we progress from layer 1 to layer 7, the amount of data is getting a bit short. This is the work of encapsulation and de-encapsulation, which is we are going to discuss again at the end of this video, and I don't know why I keep bringing it up again. Then we have a time to live, which we are going to discuss when we talk about DNS. And we have a protocol which is TCP. Then we have some flags which I do not understand. I'm not some network guy. And we have the source again, the destination again, and this is a bit of information about the network layer. Next we have the fourth layer, the transport layer. Now the transport layer is also called the heart of the Osi model. It provides the functional and procedural means of transferring variable length data from source to a destination while maintaining the quality of service. So any amount of data can be sent from a source to a destination. It is responsible for segmentation and desegmentation and provides reliability. Segmentation and desegmentation is that it takes the large amount of variable length data, divides it into small chunks, and then sends them one by one. It is also responsible for error control. It is also responsible for determining the type of protocol to be used, whether it should use TCP or it should use UDP. Now we have already discussed what is TCP, what is UDP. TCP is a connection based protocol and UDP is a connectionless protocol. So if some data was sent via TCP but the destination did not receive it, it is retransmitted. In UDP, we are just transmitting data. We do not care whether the destination received it properly or not. An example would be that HTTP is based off TCP. Since if we visit Google and we can only see the logo but not the search bar, it would not be much of a use. UDP is used in situations like video conferencing, where if some part of the video is not visible, then it's not much of a problem, since we do not want it to be transmitted again. Now let us see the fourth layer in our FTP packet. So it was the TCP protocol used, transmission control protocol. The source port was 21, since FTP servers mostly run on port 21. So it was running on port 21 on that IP address. We connected using some random port, which was 40,966, sequence 1, ACK1, length 20. So the length is decreasing as we go up. So we have source port, destination port, stream index. The TCP segment length is 20. Sequence number is 1. Sequence number would be 2 for this, I think. Okay, acknowledgement number 21. Raw sequence number a bit long. Header length 32 bytes. What is header? When we discuss encapsulation, it will be back. So we have some flags which are set. The window size, checksum which is unverified, and then we have some more data regarding this. We have some analysis that was done. We have timestamps, time since first frame in this TCP stream. So when was the first data received in this TCP stream? When was the first SYN packet received? And time since the previous packet was received. So before this, there must have been a TCP packet which was received. So what was the time between that? And then the TCP payload. So the data which we have received, which is just 20 bytes. So that was the layer 4 network layer in our TCP packet. Now we have 3 more layers left: session layer, presentation layer, and application layer. Now we generally group these together into one layer, that is the application layer. So the session layer controls the dialogues or the connections between the computers. It is responsible for establishing, managing, and terminating the connections between the two devices or nodes. The layer 6, or the sixth layer, is the presentation layer. So as the name suggests, it is responsible for the presentation of the data. So what it does is that the data that it receives, it is responsible for making it in a standardized format, for presenting it in a standardized format that the receiving computer can understand in spite of the difference in its operating system or architecture. And lastly, we have the application layer, which is the layer that directly communicates with the end user. It communicates with all the programs. For example, in the FTP protocol that we captured, the program which was communicating directly with the application layer was the FTP client program. So it communicates directly with the programs. Now the application layer and the presentation layer and the session layer are all combined into one application layer. So this last section is of all three, and it is combined and does not contain much information. Only the data that was sent is visible. This is the case with all of the packets that we have captured. So now let's just talk a bit about encapsulation. It is the process by which data is transferred from one layer to the other. Now in the process, each layer adds its own header to the data. So as you can see in this image, first we have data, then in the presentation layer a header is added to it, then in the session layer another header is added, in transport layer another one is added, and so on so on so on till the physical layer whole the data is known as bits and it is transferred to the destination device. So that is why when we observed in Wireshark, we could see over here some 80 around bits, and on the application layer we could only see about 20 bits because of the process of encapsulation and de-encapsulation. De-encapsulation is the reverse of this. What the receiving device does is de-encapsulation. It receives this bits and removes all the headers as it transfers the data upwards. Now there is one peculiar thing that you might notice. The data link layer adds a header as well as a trailer at the back of the data to make sure that it does not get corrupted during transmission, because if it does, then the receiving device can see the trailer, and if it does not find it, can conclude that the data is corrupted. One last thing we need to discuss is the TCP IP model. The TCP IP model is the one that is used in real life. It is just like the Osi model, except that the application, presentation and session layer are grouped together into one application layer which performs all three functions. The transport layer is left as it is, the network layer is called the internet layer, and the data link layer and physical layer is merged into one layer called the network interface layer. The TCP IP model has been around for a longer time and is the model that is used in all modern networks. So just one last thing before this video ends, it's really gotten really long, is that even though I can talk a bit about these topics, does not mean that I fully understand them, and I do not claim to understand them fully. If you feel that I have made any mistake or said something that is wrong, please correct me, because I would like to learn more about all this stuff, because this is really new to me and really interesting. So feel free to drop a comment, or you can contact me at my website creativerobotics.org. There's a contact form over there. So I just wanted to say this, and thank you.